What's up guys, welcome back to the channel. Today in this video we'll be solving this previous question paper that you see here. So this is a national certificate for N4 mathematics. This question paper was actually written on the 22nd November 2023 and it took about 3 hours. It was written at 9 o'clock. So we already done question 1 and question 2 of this question paper. If you are interested on watching those questions, you can go to the description. I've left those videos there. Also, I'm gonna leave the timestamp of this question. Maybe you are interested to watch 3.4, just click on the timestamp and then it will take you straight to question 3.4. All right guys, so before I start, I would like to say thank you very much guys for watching. Subscribe to the channel if you haven't subscribed, and also share these videos to your friend. All right, so let's look at question 3. All right, so this is our question 3. As you can see, question 3 consists of 3.1, 3.2, 3.3 and 3.4. so these are the questions that are in this question. Now we're gonna start with question 3.1. As you can see, question 3.1, let me highlight here. They just want us to simplify this problem here. So I will copy this and then I will paste it so that we can have enough space. As you can see, I've already copied the question here. So let's simplify this question. So first of all, we'll have to change the identities here and also the inverses. So let's start with the numerator. We know that 1 over cos squared is the same as sec squared then. So I use the inverses to change that. And then minus. So on the numerator we have tan squared. That tan squared, you can use the quotient identities and write sine squared theta over cos squared theta. Right. By the way, this solid line here represents division. So you can write it like this, and then we can say divide by 1 minus. Now look, when you look at this here, this is a 360 minus theta, meaning this is our fourth quadrant. On the fourth quadrant, cos is actually positive. So if you use the 180 rule, you can write this as cos squared theta. By the way, if you don't know about the 180 rule, it's basically the rule that we use to reduce here. You can go to the description and the icon will pop up on your top right if you understand more about 180 rule. So from here guys, we start. As you can see here, we have these two terms that are divided by cos squared. So we can say 1 minus sine squared theta divided by cos squared theta. This is also divided by the same thing that we see this side, which is 1 minus cos squared theta. Right. So here guys, we need to use some of their identities. So we're gonna use the square identities. If you still remember, let me show you this. If you still remember, sine squared theta plus cos squared theta is equaling to 1. If you make sine substitute the formula, this is what you're going to have. So if you say sine squared theta and you transpose this cos this side, you will be having the following. You'll be having 1 minus cos squared theta. Right, so this is what you're going to have, meaning that sine squared theta is equaling to 1 minus cos squared theta. Whenever we see 1 minus cos squared theta, we can substitute with sine. Do you guys see that? Right, I hope you can see. But also look at when we use the very same formula here and then we make cos substitute the formula on this one here. If we make cos substitute the formula, we're gonna have cos squared is equaling to 1 minus sine theta squared. Do you guys see this? This is when we took sine to the other side and then this is what you're going to have. We're going to have 1 minus sine squared theta, meaning now when it's like this, wherever we see 1 minus sine squared theta, we can substitute with cos. If I can draw, I can show you that. You guys see this is the same as that, right? So let's substitute. I hope you guys can see. Now let's substitute. Wherever there is 1 minus sine squared, we're going to substitute with cos squared. So let's write it. Cos squared theta divided by cos squared theta. And then this is going to be divided by, wherever there is 1 minus cos squared theta, we're going to substitute with sine. So this is going to be sine squared theta. Now this cos squared theta divided by cos squared theta is going to give us 1 divided by sine squared theta. As you can see, 1 over sine is actually the reciprocal of cosec. If you don't remember the reciprocals, you can go, guys, to the video that will appear on top there, just to remind you guys, right? So we know that this is same as 1 over sine squared theta. So this is the same as cosec squared theta. So as you can see, this is our final answer. I hope you guys understand this question. I hope you didn't get lost. If it so happened that you did get lost, you didn't understand some of the things, you can rewatch the video or leave a comment, and I will try to answer it to my level best. Alright guys, so we are done with 3.1. Let's go and do 3.2. Alright guys, so this is 3.2. On 3.2, we are given this question here. So it goes like this: if 2 cos b minus 1 is equaling to 0 and sine b is less than 0, calculate this following problem here. So this type of a question, it also needs you guys to understand certain things. So before I explain that, how about I copy this question and then let's do it. Alright guys, so we have copied this 3.2 here so that you can have enough space. So the first thing that you must do here, you need to notice where exactly you're supposed to do all these calculations. You need to find out the quadrat. So this first problem here, or this first trigonometric ratio, it will tell us the one part of the quadrant where you're supposed to do the calculation. So let's make cos subject of the formula here. So if we do the following, we say cos b, or this is 2 cos by the way, and then we take 1 to the other side, it's going to be positive 1, right? And then we say cos b is equaling to, if we divide by 2, it's going to be, so cos b is going to be positive. So this tells us that in a cos diagram like that, cos is going to be positive, right? So where is cos positive? Positive here and there, right? So we need to find out another thing that will help us to choose between the two, because these ones are out, by the way. So when you look at this one here, it says that wherever this calculation will be done, sine must be less than 0. It means that sine, wherever will be doing the calculation, will be negative. So sine b is actually negative, guys, right? It's actually negative. So when you look at this quadrant, we have the first quadrant, the second quadrant, sine is positive, but this quadrant on the third one is being scratched out. So we're gonna do the calculations here. So to clarify everything, we're gonna do the calculation on the fourth quadrant, right? So whatever we'll be doing here, it's on the fourth quadrant. Now we need to know what is cot b, cosec b, tan b, and cot b. So that is not a problem. First of all, we need to find out what is our x, y, and our radius, or our hypotenuse. So already with cos, we know that cos is adjacent over hypotenuse. We are all good there. Since this is happening on the fourth quadrant, we can say our adjacent here is x, and then our hypotenuse is r. What is missing is y, meaning our x is equaling to 1 and our r is equaling to 2. So what is our y, right? So our y, we're gonna use the Pythagoras theorem or theorem of Pythagoras to find y. So let's do it here. So x squared plus y squared is equaling to r squared. Now if we make y such a formula, we're gonna take x to the other side, and then we're gonna have y squared is equaling to r squared minus x squared. Then from there we square root, we're gonna have y, and then this is gonna be plus or minus r squared minus x squared. Now what is our r squared? So r squared here is gonna be 2 to the power of 2, and then our x squared is gonna be minus 1 to the power of 2. So if you put this on a calculator, you will have the following: plus or minus square root of 3. So which one is it? Because we have a plus or minus. Since this is happening on the fourth quadrant, y, this side is negative. You guys see, this side y is negative. So meaning our y here is going to be negative root 3. So now we have x, r, and y. Now it's time for us to do the following. Now if you still remember that cot is the same as x over y, and then cosec is the same as r over y, and then we know that tan is the same as y over x. Well guys, since we have our cot, cosec, and tan in place, we can start now. You can use this formula here. Remember, cot is x over y. So what is x over y? Remember, x is 1. Don't forget that x is 1 here. So it's going to be 1 over y. So what is our y? Root 3. Negative root 3, by the way. Negative root 3. And then plus. So we're going to add here. So cosec is going to be r over y. What is our r? Which is going to be 2 over what? Over y, which is also going to be negative root 3. All right, I hope you guys can see. And then we have this solid line here that says we are dividing. All right, and what is tan? Tan is y over x. So what is our y? Our y is negative root 3. Just write it nicely. Negative root 3 divided by x. What is our x? Our x is 1 plus, right, another cot, which is x over y. Our x is 1, and then our y is gonna be negative root 3, right? So as you can see, now it's time for us to simplify this. So we're gonna say, since the denominator are the same, underneath the numerator will add. So we're gonna have 1 plus 2, which is gonna be 3, but let's just write it, and then we have our root 3, right? And then here, since the denominators are not the same, we need to find the common denominator. But as you can see, the common denominator is actually negative root 3. So if you say 1 into root 3, negative root 3 is going to be negative root 3 multiplied by negative root 3, so the answer is going to be 3. All right, plus, right, if you say negative root 3 into root 3, the answer is going to be 1. All right, so let's continue. Now let me just create a little bit of space here, a bit guys, a little bit of space. Right, so I'm going to continue here. So when you create more, so I'm going to continue here. So when you continue on this side, it's going to be 3 over negative root 3. So remember, when you change this into multiplication, they swap, guys, right? So we know that the numerator become a denominator. So the numerator, which is our negative root 3, divided by what is 3 plus 1 is gonna be 4. So since these are the same, negative root 3 and negative root 3, they divide each other. So our final answer here is gonna be 3 over 4. I hope guys you managed to get this one. It was a bit challenging if you don't understand what is happening here, but basically you were supposed to know how to read the statement here, guys, right? You must be able to read this statement where you are given specific information to identify which quadrant you're supposed to work on. Alright guys, I hope you managed to understand this one. If you didn't understand, you can rewatch on the video and also ask a question, but this time just leave a timestamp when you're asking so that you can know what is it that you are asking. And if you haven't subscribed to the channel, subscribe to the channel, share this video, and let's go and do the next question, which is 3.3. Alright guys, so this is 3.3. So 3.3, they want us to prove the identity that you see there. So we're just gonna copy this question that I just highlighted and paste it somewhere there is space. Alright, just copied this 3.3. So they want us to prove that the left hand side is the same as the right hand side. So the best way of doing this, you must always choose the most complicated side. When I look at this question here, between the left and the right, the most complicated side is the left. So let me just choose the left hand side. Now when I look at the left hand side, you have sec 2a plus tan 2a. So you can change this sec into inverses. So the inverse of sec is actually 1 over cos. So let's do this. Just in case you don't remember the inverses, you can go to the description. I made a video about inverses. So 1 over cos 2a plus. Now for tan, you can change it into its quotient identity, which is sine 2a over cos 2a. Right, so as you can see, these are divided by the same denominator, so let's write it like this. So we can say the numerator, they're gonna add, we're gonna have 1 plus sine 2a, right, divided by cos 2a. Look, sine 2a and cos 2a, guys, are actually double angle identities. I've made videos about double angle identities. They will appear on your description again if you want to understand them, where I derive the double angle identities for sine and cos. Go and watch them if you don't understand them. So let me change this. Let's start with the 1 on the numerator. So we can also change 1 into square identity. Remember, cos a plus sine a squared, is a 1 into 1. So this 1 here, we can replace it with that. So let's change it. So let's change. We have cos squared a plus sine squared a, right, plus. Now let's change this double angle identity. So this is going to be 2 sine a multiplied by cos a, right. So we divide this. Let's divide it, right. So this one here also is a double angle identity, so we can change into this one here. We can say cos squared a minus sine squared a, right, because this one is a lot, so you have to be careful when you change this one, guys, the cos 2a. When you look at this numerator, guys, this is actually a quadratic. We can rewrite it like this. Let me just write it here. We can say cos squared a, right, plus 2 sine a multiplied by cos a plus sine squared a, right, divide by the following that is here, guys, which is cos squared a minus sine squared a. Right, if you look at this, guys, this is similar to x squared plus 2xy plus y squared. So you can actually factorize this. If we say cos is x and then y is sine, you guys see it's kind of similar to that. I hope you can able to see that, right? So let's factorize our numerator. All right, so if we factorize the numerator there, we'll be having cos a plus sine a, right, multiplied by cos a plus sine a. Let's see if our factorization is correct. If you say cos multiplied by cos, it's going to give us cos square. If you say cos multiplied by sine, we're going to have 1 sine cos. If you say sine multiplied by cos, you're going to have another 1 sine cos. When you add them, they're going to give you 2 sine cos. And then you say sine multiplied by sine, we're going to have sine square. So this is correct. Then underneath here on the denominator, we have the difference of 2 squares. So let's do difference of 2 squares. We have cos a plus sine a, and then the second bracket is going to be cos a minus sine a. By the way, this is the difference of 2 squares, guys. So from here you can see we have cos a plus sine a, which is going to divide this cos a plus sine a, and in the numerator we're going to be left with cos a plus sine a divided by cos a minus sine a. Right, so this, as we can see, this is the same as that on our right hand side. I hope you guys can see that, and I hope this was not as difficult as it seemed. What you needed to know was the double angle identities and the reciprocals or the inverses of the trigonometric ratios, and from there you just substitute and do the basics when it comes to math. Right, guys, if there is a question that you don't understand, you can leave a comment on the comment section, or you can rewatch this video from the beginning of this question until you understand again. Alright, guys, let's go and do the last question, which is 3.4. Right, guys, let's look at 3.4. 3.4, they want us to solve for x in the following trig equation. So this is the equation that is given to us. So we also been given the limit where to begin and where to end. So let me just copy this question here, and then let me post it where we can able to solve it. All right, guys, as you can see, this is 3.4. Managed to copy it and place it here. Look, guys, this one here, it's to solve for x. So we are given a domain which is from negative 360 to positive 360, meaning now we will have to circulate the cast diagram 2 times. We are moving from negative 360. Let's try to write it when we're from negative 360 to 0, right, to 0. So this one is when we are moving from negative 360, which is gonna be somewhere here, and then we move to 0. So this is how it's supposed to look like. That's the first negative 360 there. We must get the angles that belong here, right? So we know that when we are moving backwards, this is going to be negative 90, and then this is going to be negative 180, and that is going to be negative 270, and that is going to be negative 360, right? So this quadrant here, the fourth quadrant, we represent it by negative theta. The third quadrant, remember we are going backwards here. The third quadrant, we are representing it with negative 180 plus theta. And then the second quadrant, we're going to represent it with negative 180 minus theta. And then the last quadrant is going to be negative 360 plus theta. Remember, when we are moving from negative 360 to 0, so these are the quadrants. When we are moving from 0 to 360, remember, now the first 360, it's dealt with, the negative 360. Now it's time for us to move from 0 to 360. So this is going to be 0 to 360, right? So again, now these are going to change. Now this is going to be 90. It's going to be 180. And that is going to be 270 and 360. So we're going to continue, move like that. Now on this cycle, guys, on this cycle, we're going to be representing the first quadrant with theta. This one here, we're going to represent with 180 minus theta. This one here, we're going to represent with 180 plus theta. And this one here is going to be 360 minus theta, right? So don't forget, this is the first cycle, and that one is the second cycle. So let's solve this. As you can see, this is a quadratic equation, so you can try to solve it as if you are solving it. So we can factorize this like this. We can say 2 sine x, right, on the first bracket. On the second bracket, you can also put sine x there. When you look at our constant is 1, so we can say 1 here, because if you say 1 multiplied by 1, you're going to have this one. If you say 2 sine x multiplied by sine x, you're going to have 2 sine x squared. But now, which one is going to take the sign in the middle? If we say 2 sine x multiplied by 1, you're going to have 2 sine x. So if you make this one negative, you're going to have 2 sine x multiplied by negative 1 is going to be negative 2 sine x, and then this one become positive, because if you say 1 multiplied by sine, it's going to be sine, so they're going to give us that, right? So this is equaling to 0. So from here, guys, you have to solve for x. So let's start with this one here. So this one here, we can say 2 sine x is equaling to negative 1. If you transpose this one to the other side, and this one here, we can say sine x is equaling to positive 1, right? Then from here, we have to left with only sine. We divide by 2. When you divide by 2 on this one, we're going to be left with sine x negative 1 over 2. This one here is still fine as it is. So let's just write it. So from here, we say arc sine. So when you take sine to the other side, it becomes arc sine. So this is going to be arc sine. Never mind the negative, just put half there, because you're trying to find the reference, guys, right? And then here also, we're just going to say x is equaling to arc sine 1, right? So we know that this is going to give us 30. In this case, this 30 is actually a reference, right? Even here, we're going to have 90, right? So before I continue solving the x's that we are looking for, let's look at this part here. I just want to explain something. We have sine, which is equaling to a negative half. So for this one here, for this one, we are looking for the quadrant from negative 360 to 360, where sine is going to be giving us negative half. So what are those angles that you're looking for, right? So 30 is our reference, right? And then on this one here, as you can see, we are looking for the angles that will give us positive. What are those positive ones? So what are those angles that we will find from negative 360 to 360, that when we substitute them here, they're going to give us positive 1. So this is going to be a bit longer. I need you guys to bear with me. So you need to understand, for this one, we must look at the quadrant where sine is negative. So let's start with this one here, where sine is equal to negative 1 over 2. So our reference is 30, by the way. So sine is going to be negative on the fourth quadrant and the third quadrant. but it's positive here, guys, right? So for this one here, let's do it. So how do we represent this quadrant? Since our x is our reference, this one we say it represented by negative theta. So our theta here is 30. So we can say the first answer is negative theta. Right, that's the first answer. The second answer, remember, sign is negative here. So how do we represent this quadrant? It's x negative 180 plus theta. What is our theta here? Our theta is 30. So you're going to put the reference angle, and then we know that it's going to be negative 150 degrees. Okay, let me just create more space. All right, so this is where sign is going to be negative. Now let's look on the second cycle. Again, sign is negative here and there, right, but positive there and there. Right, now we are moving from 0 to 360 now. So how are we going to do this? On this cycle here, we know this is going to be, remember we are moving this way this time around. It's going to be x is equal to 180 plus theta, which is our reference. So it's going to be 210 degrees. Right, last but not least, as you can see, sign is negative here on this quadrant. It's going to be 360 minus 30. So as you can see, this is going to be 330 degrees. Guys, these ones here, these answers that we got here, if we substitute them on sine x, we will have negative 1/2. Alright guys, that's how you do this one here. Okay guys, what about when we have sine x is equal to 1, where sine is going to be positive? So we're going to look at on the very same quadrant here where our sine is positive. So sine is positive on the first quadrant and the second quadrant. Right, so let's start on this one here. So you're gonna do the very same thing here, guys. This is how we represent this quadrant. When you go backwards, it's gonna be negative 360 plus theta. So let's do it here, guys. Let me just try to do it here. So x is gonna be negative 360 plus theta. What is our theta? It's 90. There we go, it's 90. So our answer is gonna be negative what? 270. As for when we go to positive side, it's gonna be this 90. So as for this one, it only has two answers here. It has 90 and negative 270. Guys, this is how you do this problem here. I hope you are not confused, guys, because it is a lot of things that you need to know. Just in case you didn't understand, you can leave a question on the comment. Also, don't forget to like the videos, subscribe to the channel if you haven't subscribed. If you didn't understand, rewatch the video again so that you can understand better. At the end of this video, there is a playlist that shows question 1 and question 2. This question 3 is going to be included in there, and there is video of question 1 there. Don't forget to click on that video if you want to watch the entire question paper. Thank you very much, guys, for watching. Till next time.